Hello, welcome to the first day of the new chapter in Chapter 2. Today we're going to learn about angles of rotation. Now, in the past, we've learned about angles between 0 and 90 mostly, and a little bit of 0 between 0 and 180. Today we're going to go and expand that. Now, an angle is in standard position. Every once in a while, I'll say an angle is in standard position. And what I mean by that is if we draw it on the axis, its vertex is going to be on the origin. So the vertex is going to be on the origin. Its initial side is along the positive horizontal axis. So positive horizontal axis will be out here. Then it is measured by rotating the initial side, this side, to a terminal side in a counterclockwise direction if it's positive. So if I moved it here, that would be, say, 30, 40 degrees. And that would be 90, about 135, 180, and it keeps going around and around, 270, 315, and so on as we go around the circle. So this is called the initial side, and this is called the terminal side. Now here's some examples. If it's positive, it's going to be going up, so say that's about 63 degrees. A negative angle would be rotating not counterclockwise, but now clockwise, so that's negative 120 degrees. 145 is just going past 90. I could say the angle 660 by going around once and then coming back. So this would be the same direction as, say, 300, because 360 minus 660 is 300. Now you don't have to draw this spiral going around and around, because sometimes if we say like 1800, you don't want a mess of circles. We just want to know what direction 660 is going to go in. Now, those last two angles are what we call coterminal angles. They're angles whose measures differ by a multiple of 360 degrees. So one example is 210. If I add 360 to that, it will be 570. Now, if I subtract 360 from 210, I get negative 150. All three of these are coterminal, and coterminal angles are always going off in the same direction. Now, which angle measure is coterminal with an angle in standard position with a degree measure of 40, but lies between 360 and 720? Pause the video, go through this problem. All right, 40 degrees is going to be somewhere up here. Then if this is 40, I can add 360 to it to get to 400. And since 400 degrees, it's supposed to be a degree, not a 4,000, 400 degrees is between 360 and 720, so this is the answer that I'm looking for. Find the angle between 0 and 360 that's coterminal with 575. Well, what we can do is take 575, that's a 5, minus 360, and we'll have 215. So if I drew this out, 215 is going to be somewhere over here, and so is 575. Now a reference angle. Reference angles are extremely important for this chapter on through the rest of the semester. A reference angle is a positive, acute angle between the horizontal axis and the terminal side. Seems easy. So if I'm over here, if this is my angle, I want a positive acute angle. So acute means it has to be less than 90 between the horizontal axis, so this is horizontal, and this terminal side. So my acute angle, my reference angle, is going to be that angle right there, because it's going to be positive, it's going to be acute, and it's going to be between these two sides. Now, finding the reference angle, we draw the terminal side of the angle, then we draw a triangle down to the x-axis, just like how we just did, and then the reference angle is the angle between the x-axis and the terminal side. So here's a couple examples. 45 degrees, the reference angle is 45 degrees. Over here at 110 degrees, the reference angle, if I drop it straight down, is going to be 110 minus 180, so that's 70 degrees. Over here, 210, we draw it up to the horizontal axis, remember, every time. And so that would be 30 degrees because 210, this is 180. The difference there is 30. So that reference angle is 30. And over here at 315, go up to the horizontal axis, that's going to be 45. All right. Now remember, all of the triangles that you're going to create have to go down to the x-axis. So in a way, it kind of makes a bow tie. If your triangle isn't part of the bow tie, then you might have made a mistake. Some people thought that this looked like a butterfly in the past. I think it looks more like a bow tie. Some people say it looks like some Star Wars jet fighter. Whatever helps you remember it, I'm fine with you calling it whatever. All right, so you guys try this one. Pause the video. See what you come up with. All right, 130 degrees. This is 180. This is 90, so it's somewhere in here. And if this is 130, our reference angle has to be 50. Find the reference angle for 330. Pause the video again. 330 is over here. So if this is 330, if we're going up to the x-axis, that means that angle, reference angle, has to be 30. 200 degrees. It's going to be a little past 180. And we'll call this angle 20 degrees. It's just barely past 180. So, because there's 20 degrees between 180 and 200. Negative 23 degrees. We drop it down. That angle is going to be 23 degrees. So that's just the reference angle. Negative 330. So this is negative 90, negative 180, negative 270, negative 330 is over here. So that means that there will be 30 degrees as a reference angle. All right, how about 1130? So if I start this out, if I go around once, that's 360. Go around again, that's 720. Go around again, that's 1080. So 1080, we can take 1130 and 1080 and subtract them, and we'll have 50 degrees. So really, we're just going up 50 degrees. So that's my reference angle. Now, some people who play a lot of video games remember this from skateboarding games. So they're able to go 360, 720, 1080 pretty quick. All right, so 1675. So we know 1080 is 3 times around. If we go 4 times around, that's going to be 360 plus 1080, which is 1440. Subtract that out. We have 235. Now, some people are tempted to put 235 as their answer for this, but that's not correct because the reference angle isn't the coterminal angle. So 180 is there, 270 is there. In between here, it's 235. So if this is 180, the angle in here is going to be 235 minus 180, which is going to be 20 plus 35, which is 55. So my reference angle is 55 degrees. Now, each degree can be cut up into minutes and seconds. Now, this is hard to see because between 0 and 180, there's 300, or on a straight line, there's 180 degrees. So there's 180 little degrees here. So if I cut one up into 1 degree, it's going to look like that. Now, in this little section, we can cut that up into 60 small sections, and each of those small sections is going to be called a minute, also written like this. And each of those minutes can be divided into 60 seconds, which can be written like that. So there are much smaller units than degrees that we can use. Here, if we find the reference angle for an angle in standard position measuring 195 degrees in 25 minutes, we just go around 180. This is 195, 25. So subtract that from 180. And we are going to get 15 degrees and 25 minutes. Find the reference angle for 242.3. All right, 242.3, well, this is 270. 242.3 is here. Subtract that from 180. 242.3, subtract from 180, and this is what, 63? 63 degrees and 3 minutes. What about 147.13? Try this one. Well, what we have to do is we have to take 180 minus 147.13. Now this gets a little tricky because when we're subtracting, we don't have any minutes here. So what we need to do is borrow a minute from 180. 1 minute equals, or borrow a degree, which equals 60 minutes. So now 60 minus 13 is 47. And now this subtracts to be 32 degrees and 47 minutes. So just borrowing 180 can also be written as 179 plus 60 minutes. So we can subtract that to get what we got on the previous problem. So find the reference angle for the standard position for this. Pause the video. All right, it's 123. So what we're going to want to do is take 180 minus my 123 degrees, 36 minutes. So as we do this, you take 1 away from 180 and to get 60 minutes. So this would be 24 minutes, and this would be 56 degrees. So 56 degrees, 24 minutes is the answer. Find the reference angle for the standard angle with standard position of 192.12. So 192.12 is going to be past 180. So I can just take that minus 180. So this is one of the easier problems. To get 12 degrees, 12 minutes. Now when we have minutes and seconds, sometimes you have to borrow from each of those. And 1 minute equals 60 seconds. So this can be written as 179 and 60 minutes, which can also go down to 179, 59 minutes, and 60 seconds. So if we subtract, say, these out, this would be 9 seconds, 46 minutes, and 32 degrees. All right, here's your homework. Good luck.